Hey everybody, Mr. Tannen here. So, make a quick video going over 3 examples talking about transformations. They're going to sort of build up. I would recommend you watch this at 1.5 or 1.75 speed. I personally like doing that with Salcon because I think interpreting can sometimes be faster than speaking like the way I'm going right now. So, this first question is just asking to describe transformation. Um, and I'm jumping back to the textbook here because this actually corresponds to section 4.7 in the textbook describing transformations. I'm really looking at examples that are like examples 2, 3, and 4, which are similar to the problems that I assigned for the asynchronous today. So, if we are to describe the transformation here, well, let's look at what's happening. We have the parent function f of x, and its transformation is represented by g of x, where we have 4 times the quantity x plus 2 being cubed. Then we could graph each function. So what we see here is we could look at that chart that was quite helpful. We actually have it probably in our notes, but it's also there on page, I think, 206 in the textbook. Well, the plus 2, it would be a translation left 2 units, and then a vertical stretch by a factor of 4. So our original function, we could just do a sketch for this, and Desmos can also be helpful to confirm. Our original function is something like this. It goes through, well, -1 cubed is -1, and 1 cubed is 1. Then 2 cubed is 8, so it's going to get steep quite quickly. I guess I should, this is going to be more like this. So if I shift that left 2 units, then stretch it, it's going to be here, but instead of going through 1, 1, it's going to go through 1, 4, so it's going to be quite stretched like this. Not a very good sketch, but good enough. Not too bad on those ones. Use the chart for those. I think it'll help a bit. Number 3, this corresponds to example 3, I'm pretty sure. So here it's giving us this function. Okay, it's 5th degree, 3 terms. And g of x, the nice thing here is they're giving us the function notation, negative f of x. Write the rule for g and then graph each function. So they basically tell us what we have to do. In this case, we're just doing, I believe, since it's vertical because it's on the outside, and it's reflecting the whole function. So if g of x equals negative f of x, I'm just going to rewrite what they gave me there. Well, that means g of x is just going to be negative times the whole thing. X to the 5th minus 4x plus 6. Okay, negative x to the 5th plus 4x distribute to negative minus 6. Wow, that wasn't too bad. So what I could do here is, if I have my graphing calculator, this could be a nice tool for this one. Let me pull it up. If I have that x squared, I believe, oh no, x to the 5th. What am I talking about? X squared. Let me clear this out. I got some funky business in here. X to the 5th minus 4x, I believe it was, plus 6. Let me do my normal zoom. I hit zoom standard. And you'll see here that my it's this cubic function. So when I end up doing just the negative of that, it's going to be all just flipped vertically. So it will come down and then have a local maximum there before then going up here. And we could, if we like, take a look at that. So it will be a negative x to the 5th plus 4x we had. Oops, forgot to hit the arrow. Plus 4x minus 6. So everything is just switched signs, not too bad. And hopefully we'll see some symmetry in this about the x-axis, this vertical reflection. So if I wanted to graph it just briefly by hand, let me see, I like the way they use blue and red there. Okay, so blue was like this, and red was like this, the opposite. Close enough, not too shabby, Mr. Tannen. Let's keep it rolling. Wow, we're making quick work of these so far. Number 4 is the last example, so let the graph of G be a horizontal stretch. So now they just tell you the transformation, and we're going to have to come up with the function notation. Horizontal stretch by a factor of 2, followed by a translation 3 units to the right of the graph of f of x. I like to rewrite it in this case. So I have f of x, a cubed plus 3. So what is g of x in terms of f of x? That's what we're first going to do. That's what they gave us on the last one, but it's not given here. So first it's a stretch, horizontal stretch by a factor of 2. Okay, I remember that's reciprocal, or it's counterintuitive as we talked about. So I'm going to have to multiply, go right to the x. Okay. And then, well, I got to keep going, so I got to go right to the x again. And I got to then shift it 3 units to the right, so it'll be like this. Wow, that's quite funky. Let's take a look if this works. So actually, this is what g of x equals, not the previous one. Because remember, you might say, why did you put these parentheses? Well, you always got to go right to the x. And instead of having x, I had 1/2 x, but then it said followed by 3 units to the right. So I had to go in and replace that x with this x minus 3. So what we could then do is we could plug all this in here if we like. So I may simplify first. We could plug it in, so we're going to get g of x is going to be 8 times 1/2 x minus 3/2 cubed plus 3. Does it say to get it in standard form? Oh no, so that's not too bad. We got the rule. Didn't say standard form. So we could go to our graphing calculator once again and test it out. See if this looks like a horizontal stretch by 2 and then a shift right 3. So let's clear these out. Clear, clear. So original function was 8x cubed plus 3. Right? Yep. Okay, so that's what it looks like. Cubic function, it's a narrow one, and then what did we say? So this is then just going to be 1/2. This is always tough. I like to put in parentheses around the 1/2. I know some of your calculators might do it automatically. I don't know why mine's not doing it. I believe we have minus 3/2. That's PEMDAS, so I don't need to the third. Plus 3. Okay, so this should be shifted. Well, first it should have been stretched wide, so it should look a little bit flatter, and then shifted to the right 3 units. Looks good, right? It's slightly wider. It was stretched by a factor of 2 horizontally, then shift to the right 3. Looks like a pretty accurate graph. So for my answer, well, I guess this is the nice thing about digital learning. Snapshot this, Johnsky. Copy, paste. Okay, I got my graph right there. How you like them apples? Okay, not too bad. Okay. Alright, well. Looks like we got our function. You might say, Mr. Tan, I went through all the work of multiplying it out. Well, that's okay if you did that, but this one, when we end up cubing, as we know, it could end up with a lot. So It was different when we had the one in class that we could just, like, it was just squares, and then we had, like, we were cubing something that was a little lighter, like just 3x. This one, if it's not saying standard form, I'm okay with this rule. Let me see if that's the same format the textbook put the answer in. No, not at all. Interesting. I see what they did. They had this answer, which is actually equivalent. I guess what they did was they cubed no. I just paused the video, but I think we found a mistake in the textbook. Because this is the textbook answer. And that's not actually horizontally stretched at all. I'll show you. I investigated it on Desmos here also. And it's definitely not a horizontal stretch by a factor of 2. We got to write to the textbook writers. Look, here it goes to negative 0.5, right? So if we horizontally stretched it, that means that the same spot over here should be going over 1 whole unit. So it goes from 3, it should go to 2 here, but it doesn't. That's why I think my answer is correct. And I think the textbook was wrong. Because if you look at my answer, look, it now goes at 2 there, right? It's been stretched twice as wide. Alright, well, interesting. Hope you liked this video. I guess what, one other thing I'll show you right quick though is since this textbook answer was wrong, there is one thing I could show you that could clean this up a bit. Is if instead, I mean, this is a perfectly fine answer, but let's say we wrote it as 1/2 times, we factored the 1/2 out that we had just multiplied in. Well, we could rewrite that this way. Well, check it out. Put both those to the third power, that's 1/8. 1/8 times 8 is just 1, so we could actually just write this as x minus 3 cubed plus 3, and you'll see that that's actually exactly the same if I graph it. This whole funky business would actually probably look better if I did it this way. See, they're just right on top of each other. But I gotta write to the textbook, we caught an error. Hopefully they send me a big prize. Much love, everybody. Have a nice day.